Welcome to another opportunity to learn. Today we're going to talk about the law of large numbers. And I wish I had my own theme music. I wish these videos need that. They need the same song on every video just to kind of get me going. Maybe I'll make one of those songs at some point. Anyway, law of large numbers, beautiful little topic. Let's talk about it. As kind of a definition, it just simply states that probabilities will match reality after many, many observations. And I need to hedge my bet just a little bit, okay? So I don't know if we'll match reality, but we'll approach reality is probably a better word. We'll approach reality. May never actually totally get there. And what I mean by that, if we think about dice, let's just think about dice for a second. What's the probability of rolling a 6 with one dice? Well, let's think about that. You got 6 on a fair dice. There's 6 sides. One of them is a 6. And so the probability of rolling a 6 is equal to 1/6, which is approximately 0.167, or about 16.7%. So 16.7% of the time, I should roll a 6. Okay. So if I were to do 6 rolls, how many 6s should I expect? And the answer is, drum roll, 1. But you and me both know that if I roll this dice 6 times, I might not get 1 6. I might get 0 6s. I might get 5 6s. Right? And so what we're saying is like the reality of how many 6s you get might be different than the probability, which says you should get 1. But you might get 0. So what the law of large numbers says is that, but if I were to roll it, say, 6,000 times, I'm very certain that my number of 6s will be really close to 1,000, or 1/6 of the time. Okay, so let's see how this works. All right, so I'm going to roll these 6 dice and see how many 6s I get. All right, feeling lucky. Though they went all over the place, I didn't get any 6s at all. I got 4 1s though, but I didn't get any 6s. So my number of 6s is 0, and that would mean 0%. So when we talk about like reality, we're talking about theoretically what should happen, which is different than what does happen, because what should have happened is I should have got 1 and I got nothing. Damn, that hurts, man. I'm glad I didn't put no money on it. Oh my God. Okay, so now, of course, I'm going to have to fast forward this, so you don't have to watch all of my simulations, but I'm going to do it again. So I'm going to roll 6 more dice, so that'll be 12 total. I'm going to count how many more 6s I get. Ooh, how many am I going to get? And I got 1 6. Yes. Joyous of all joys. That's 1 6 there. Oh gosh, 1 divided by 12. Oh, where's my calculator go? Oh, 1 divided by 12 is 8.3. I guess I should have figured that. It should have been half of that number, but whatever. Okay, so we're going to go, that's about 8.3%. So a bit closer to what it should be, but again, probability plays out over many, many observations. We've done 12 observations so far. Let's do a few more. I'm going to do fast forward, but let me roll some dice. All right, welcome back. So we rolled 120 dice, and we got total 22 6s. 4 means 18.3% of the time we got a 6. Now, theoretically, it should happen 16.7% of the time. So you can see that it didn't exactly pan out, but it's getting closer and closer to approaching reality. So if we kept going, if we kept on going to like 1,000, we would be pretty confident that whatever our answer is, it's going to be getting quite close to what we would expect. It's going to bounce around, maybe it dips slightly below, slightly above, but it'll start to settle. And then if you get to 2,000, it's going to be right there around that 16, 17 range. And you'll see with more and more simulations, all of a sudden, what we thought was going to happen is what happens. Probabilities play out after many, many instances. So early on, right there, that was perfect. So there you go. But, it moved after that. And right before it was, pretty far off, 11%. But if you do it a whole bunch of times, it starts to work out. That's why they say the house always wins, right? That's why those casinos are so big, right? Because they know their games, they're going to win more often than they lose. And so what they rely on is just enough people to play. Because you walk into a casino, I'm not here, I don't recommend gambling. I don't gamble, but you might win that first or second time. But if you stay in the casino all weekend, if you stay there for a while, you are going to lose. Because eventually, the house always wins. Eventually, probability corrects itself, and your final results are what you thought they would be. I'm going to show you one more simulation, but to do that, I got to jump over to Zoom. So I'll see you there. Take care. Okay. Hey, my first time I'm recording a screen on one of these videos, but I want to show you this applet. So here we go. We got this shooter, this free throw shooter. They're 80%, but we're not supposed to know that they're an 80% shooter. We're trying to figure out how good they are. Okay, so let's have them take a shot. First shot, it makes. We're 100% so far. Let's do another one. Oh, again. But right now, if you were just to stop, this person is 2 for 2. So does that mean they're a 100% shooter? Probably not, because 2 shots, law of large numbers isn't enough observations to be confident that what we're seeing is matching, the reality we're seeing is matching the theoretical reality. So let's shoot again. Made another one. Okay. Oh, we got some missed a few. Now we're going back up. Now this shooter is exactly 80%, right? It's just doing an 80% probability, so you can see what happens. Now let's take a whole bunch of shots and see what happens in the long run. And what we should see is that after many, many free throws, probability is going to take over. And that if somebody is actually an 80% shooter and they shoot 100 free throws, you would expect them to make about 80 of them. And that's what we're seeing here. You can see that the amount of variation starts to decrease, and we start to get closer and closer to that reality. Now, I don't know how many shots we'll need in order for it to get right at 80, because I don't know how many is. Theoretically, an infinity amount of shots. So we just say, okay, look, now it's at 79. That's pretty close to 80. And that's how probability works. In small increments, might not match reality. But if you do enough, if you just keep doing more and more observations, the probabilities that you're observing will match the theoretical probabilities. Okay, so that's what I wanted to show you. It's called the law of large numbers, and just says, look, if you observe many, many times, you can be confident that what you're observing is going to match the reality of the situation. Okay. You're so beautiful. Thank you for watching this video. I hope you're well, and I'll see you sometime. Okay. Bye-bye now. Oh, that wasn't a bye-bye. This is a bye-bye. Stop recording.